In the next few videos, I want to tell you what you need to know about trigonometry to make it through an AP calculus class, and specifically kind of going to focus in on the stuff that you need to know for every day and the stuff that you need to know for just once or twice. Okay, so we're going to start off with the basic definitions from trigonometry, and this is going to be a little bit of a rush job, but this is pretty old material from back in Algebra 2 or geometry days. All right, so we have here a triangle, and I've got one of the acute angles marked. We typically use the Greek letter theta to indicate the size of an angle. And so we've got names for all three sides. So this leg, which is right next to angle theta, is called the adjacent leg. The leg on the opposite side is called the opposite leg, and the long side of a right triangle is called the hypotenuse. Okay, so we've got three different primary trig functions. We've got sine and cosine and tangent. And so all of these take an angle theta, as its argument, and they all return a ratio of two sides of the triangle. And so the magic word that people sometimes remember is SOHCAHTOA. SOHCAHTOA. And if you're an older person, you didn't necessarily remember this word, but you remember a sentence that started with these letters. For instance, the rule that stuck with me is some old hippie caught another hippie tripping on acid. So the idea is that you remember these 9 letters using some process or other. And here's what you do with this. So the sine is the opposite over the hypotenuse. The cosine is defined as the adjacent over the hypotenuse, and the tangent is defined as the opposite over adjacent sides. Okay, so if you knew the length of these three angles, you can just divide them out, and that tells you what the sine, cosine, and tangent of those three angles are. There are a couple of basic identities that are very handy to know in calculus. And so I'm going to deal with two of them right now. So for instance, let's think about the sine of theta divided by the cosine of theta. So the sine of theta is opposite over hypotenuse, and the cosine of theta is adjacent over hypotenuse. All right, and we can either multiply both the numerator and denominator of this by the hypotenuse, or if you're used to it and want to make a little use of your middle school knowledge, you can remember that dividing fraction by a fraction is a question of keep, switch, flip. So in dividing, instead of dividing, we're going to multiply, and we're going to flip the denominator over, take the reciprocal. So the two, either way, whether you're multiplying both the numerator and denominator by h or doing this, the h's cancel out and you're left with O over a, which is the definition of the tangent of theta. Okay, so this is a basic identity that the tangent of theta is equal to sine of theta over cosine of theta. All right, let's take a look at one other key identity, which is in here. Let's calculate the sine of theta squared. We usually write it like this. So if I wrote sine of theta squared like that, you wouldn't know if I was squaring theta or squaring the operation. I could write it like this, but traditionally mathematicians write the argument over the sine. So this means we're calculating the sine of theta and then squaring it. So the sine of theta squared plus cosine squared of theta. So let's figure out what this is equal to. So once again, sine of theta is opposite over hypotenuse, and we're squaring that. And cosine of theta is adjacent over hypotenuse, and we're squaring that. So that becomes O squared over H squared plus A squared over H squared. And since these two fractions have the same denominator, we'll just combine them. And if we look at this, A and O are the two legs of a right triangle. And we remember the Pythagorean theorem. So A squared plus O squared is equal to H squared. That's what the Pythagorean theorem says, is that the square of the hypotenuse is the sum of the squares of the two legs. So this is equal to H squared over H squared. And those just cancel out. And so that's equal to 1 no matter what theta is equal to. So the other useful identity is that sine squared of theta plus cosine squared of theta is equal to 1. And because we use the Pythagorean theorem to solve this, we very often call this the Pythagorean identity. Okay, so here's what you need to take away from this video. That you need to remember the definitions of sine, cosine, and tangent. You need to remember the tangent identity, and you need to remember the Pythagorean identity. All right, so these are all helpful things that will get us through the unit talking about trigonometry. In the next video, we're going to go a little bit deeper, and we're going to talk about the secondary trig functions, which maybe you haven't seen before, but they're going to be handy things for you to know.